Happy New Year and welcome to the Titus Timeout podcast. I'm Jenny Abney-Civy, and my first podcast of 2015, I'm going to discuss VAV box minimum CFMs. In previous podcasts, I've mentioned minimum CFMs or minimum CFM required for heat, but I want to kind of pull it all together today. Let's start with the primary air inlet. Our catalog shows the airflow range of the different inlet sizes. So let's show inlets and CFM range here. So for a size 4 inlet, the CFM range is shown as 0 to 225, a 5-inch 0 to 350, 6-inch 0 to 500. And let me write out the rest of these. And we'll stop at 16, which is 0 to 4,000. Okay, so on the low end, 0 is obviously closed, but could you put, say, 1 CFM or 10 CFM through a size 10 inlet? I mean, you probably could, but you're not going to be able to measure it. So manufacturers publish minimum CFMs. So the minimum CFM is based on a couple things. First, it's based on what the VAV controller can read as a minimum pressure differential signal from the flow sensor. Since the signal is coming from the flow sensor, it also is based on the flow sensor signal. Okay, so let's draw a VAV box. You're just looking into the inlet. And in our inlet, we have a arrow cross flow sensor. If you remember from one of the previous podcasts, there's 4 ports on the front, which are reading total pressure. There's 2 ports on the back that are reading static pressure. I'll put a little asterisk here and come back to this in a minute, but the idea is that total pressure equals velocity pressure plus static pressure, or said another way, velocity pressure equals total pressure minus static pressure. So if you can know your total pressure and your static pressure, you can calculate your velocity pressure. You can use that to calculate velocity, which is 4,005 times the square root of velocity pressure. And then you can use your velocity to calculate your CFM, which is velocity times area. Right? So you have velocity pressure, which gets you velocity, which gets you CFM. So let's talk about this asterisk a little bit. I mentioned the minimum pressure differential that the controller could read. So let's talk about where that pressure differential comes from. The ports off the flow sensor are connected to a pressure transducer on the VAV box controller. This pressure transducer is looking at the difference in these two pressures to come up with this differential pressure. So the higher you can make the difference between the total pressure reading and the static pressure reading, the better. So what you do as a manufacturer is we design our flow sensors so that we amplify the difference between these two signals. By doing this, you create a greater differential pressure, which allows you to read to lower CFMs. That brings us to the flow sensor's K factor. You've probably heard of the K factor. It's something you put in your controller so you know that for a Titus sensor you need to use this K factor. But what that really is the CFM for that flow sensor where delta P is 1 inch, where delta P is the difference between your two signals here. So for a 10-inch arrow cross, the K factor is 1436, basically saying that at 1436 CFM, the pressure signal, delta P, across the flow sensor is 1 inch. So that's a little more than I wanted to get into, but I needed to explain that to talk about the minimum pressure calculations I'm about to do. So now that we know our K factor, we can calculate our CFM using this equation. CFM is the K factor times delta P, where delta P is the signal that's going to the pressure transducer And we're going to use 0.01 inches as the minimum pressure differential that a typical pressure transducer can read. So that will give us the minimum that can go through a box for a typical VAV box controller. So now let me throw in my disclaimer. Your VAV box controller may differ. You may not be able to read down to 0.01 inches on the pressure transducer of your VAV box controller, so you should find out from your control guy what is the minimum differential pressure it can read so that you know that you can get the minimum you're trying to hit. Okay, so now let's calculate the minimum CFM of this 10-inch box that has an error cross in it. The CFM is the K factor, 1436, times the square root of 0.01, which is 143.6 CFM. I think our catalog says 145 because we round it up. So let's go back up to the top and let's put in our minimum CFMs based on the inlet size now. So size 4 is 30, size 5 is 40, 45, 70, 90, and so on. Okay, so now let's move on to another minimum CFM that's important, which is the heating CFM, specifically for electric heat. So per UL, we have to have a thermal cutout and an airflow proving switch in boxes with electric heat. If you exceed 125 degrees, the thermal cutoff will shut off the heater. So the equation for electric heat is kW equals CFM times delta T divided by 3160. Or if we solve for CFM, it's CFM equals 3160 times kW divided by delta T. So we can calculate the minimum CFM for 1 kW. That gives us 125 degrees. 3160 times 1 kW divided by 125, because that's the maximum temperature we're calculating for, minus 55, which is the supply air temperature of, say, a single duct box. And that comes out to 45 CFM. And since it's 1 kW, it's basically 45 CFM per kW is where the thermal cutouts will start tripping. So this is the absolute minimum CFM that you can have and not exceed this 125 max temperature. So make a little bit of room here, and let's look at this. ASHRAE 62.1 recommends that less than 15 degree delta T be supplied to the space. So for a 75 degree set point, this is a 90 degree supply air into the space. So let's make that 95 degree leaving air temperature from the VAV box itself. And let's do our CFM calculation again now. So CFM equals 3160 times 1 kW divided by 95 minus 55. And that equals 80 CFM, or again, since it's 1 kW, 80 CFM per kW. Because of this, we recommend that you have at least 80 CFM per kW in electric heat applications. So let's bring everything back on screen here so you can kind of reference all of it. That covers VAV box minimum CFMs. Don't forget to subscribe to our YouTube channel, and thanks for taking the time out with us.